Hello, my name is Clayton Lindsay. Welcome to March 23rd, Minnesota Astronomical's beginners groups, special group, um, virtual presentation. And this month, this is the last virtual presentation we'll have for this winter season. And we welcome back Ahmed Reda for part two of the golden age of medieval Islamic astronomy. I'll let him take over, but before I do, I just want to remind everyone that the next BSIG meeting will be a outdoor star party at Metcalf, and that will be on the east side of St. Paul, and you can find that. I have a link to it in the chat, and you can find the information and directions to that event. So I hope to see everyone there, and it is a public event, so you're welcome. Anyone's welcome. And without further ado, here's Ahmed Reda.
Thank you, Clayton. Thanks, everybody, for joining. For those who don't know me, I'm Ahmed Reda, and I am a member of the Minnesota Astronomical Society, and I've served multiple functions within the club. And one of the things that I enjoy the most is looking into the history of astronomy throughout civilizations in the past and how the things evolve and the thought process. And this presentation will be in the same context of the same one that I did about a year ago, which is looking at thought process and how it evolved specifically during the medieval Islamic period, where it acted as effectively as a golden age for astronomy. So sorry, I got muted. Can everybody hear me?
Yep.
Okay. So what part one was, we covered, pre-Islamic astronomy and how it effectively was in the Arabian Peninsula. It was primarily astrology. And then, we talked about how, Islam brought a very rationalistic approach to science and caused a revival in astronomy. And there was Beit Hikmah, the House of Wisdom in Baghdad, which was a center that was duplicated all over the Muslim world at the time. And effectively people started developing more and more scientific, specifically astronomical theories. And we covered, for example, Al-Firghani's Earth circumference measurement and how he came very close to the actual measurements that we have today. When you look at the Middle Ages, he has the closest calculation from an Earth circumference standpoint compared to anyone else. Everybody missed it by a big margin, although they tried different good techniques, but he's pretty accurate. And then we talked about Sufi's books of fixed stars and how the start of actually giving names to all the stars, because we want to study them and we want to map out the sky beyond just the constellations. And we talked about Khwarizmi, the one who invented algebra, and Zij books, which were effectively codifying how do we do star charts and star tables for measurements for locations of stars throughout history, ending the presentation with Ulugh Beg Observatory and School for Astronomy and how he got really good calculations for the position of the sun and estimating the duration of the year and the moon orbits and other factors. If you want to go back to that presentation, you can watch it on the Minnesota Astronomical Society YouTube channel. There's also amazing videos out there from other BSIGs and monthly meetings. So I recommend go out there, watch it, and also subscribe for the channel. So the main thing that I will carry on from the previous presentation is that within less than a century, the Muslim empire stretched from Western Europe and Spain and Western Africa and Morocco to Central Asia. And effectively that spread in civilization for the first time in a long period of time. Before that, there were the wars between the Romans and the Persians, ravaging that, the ravaging from the Middle East, and then, the Turkic tribes were coming in from the north. There was a lot of turmoil, but for the first time, for a couple of centuries, you had a period of peace where caravans can go from one far end to the next. And with that travel of caravans, you have knowledge moving. And then you have all the races and the groups of people actually contributing to the sciences and technology. Now that there is no war, they can develop things and proceed forward. And effectively, the scientific revolution in that time initially started with, an exchange of knowledge that led to the ancient texts coming out and being translated to Arabic. And after the translation phase, people shifted gears into, okay, let's start critiquing that text more. What makes sense? What doesn't make sense? And then after the critiquing phase, people shifted gears more into towards, okay, let's start developing our next set or phase of theories, building on that knowledge. So the scientist, today we'll talk about a specific scientist who was by himself an encyclopedia. And he came in the phase that he started initially with critiquing ancient texts, specifically Aristotle and Ptolemy. But then as he was doing the critiquing, he was developing a lot of theories that nowadays we have actually specific terms to, like gravity and other and elliptical orbits and so on. And at that time, the language of science became Arabic because it was the language that joined all these people. People spoke local languages, but all the books and everything was written in Arabic due to the influence of the Muslim conquest and culture at the time. So the scientist we're going to talk about today lived in, at the time it was called Khwarazm, which is currently in Central Asia, and we'll get to talk about him in more detail. But a highlight of that, another highlight from the previous presentation was just quickly here. There was the House of Wisdom in Baghdad, which was effectively the very first institution. It was built by the Abbasids in the 8th century, in the middle of the 8th century, and the objective was, let's actually bring texts from every different background, from Chinese, from Greek, from Hebrew, from Sanskrit, Persian, etc., and let's translate all those to Arabic, and then let's bring in students. Let's actually start educating people. And there were thousands upon thousands of manuscripts in there. This is where the Almagest, for Ptolemy, after it got translated, got housed. The final, we talked about 4 iterations of attempting to translate it. The final one happened here. This is where the books of Ptolemy and others got translated, and that's how we know about them nowadays. But effectively, it built a model that was duplicated in other parts of the Muslim world, in Cairo, and Samarkand in Central Asia, and Cordoba in Spain, and Kairouan in North Africa, etc. So this was a model that was duplicated, and the kind of scientific research over there was duplicated too. And the scientist we're going to talk about today, his name is Abu Rayhan, Muhammad ibn Ahmed al-Bayruni, and he lived in the 10th century into the middle of the 11th century. And he was born, as I said, in the region called Khwarazm in Central Asia, outside the city of Kath. Actually, the name Beirun itself is an old Persian word that means outskirts. So it pretty much was saying, okay, this is the guy who came from the outskirts. And you can see here on the map, pretty much the city of Kath is over here. This was a pretty rich region with agriculture and everything. And as you can see, the Amurdaya River that was mainly fed by rain, and then it drained the fluid into the Aral Sea at the time. This was a pretty lush region, very fertile, very affluent. Unfortunately, the satellite picture here in the upper right corner shows what it looks like today. In the Soviet Union, directed the water for agricultural purposes to other parts, and it effectively led to the whole place dried up. As you can see, it's much smaller. You can see here the basin where it was supposed to be. It's much smaller than what it used to be, and that area is suffering from desertification today. But in the Middle Ages and even during antiquity, this was a very rich, very affluent region. And he studied in that region. There are multiple cities that he studied in, and he studied, usually at the time, people would start by studying, the Islamic theology and Islamic jurisprudence. You start with that, and then they would graduate, okay, grammar and literature, how to write, and then they would graduate to studying actually mathematics, astronomy, and then medicine and philosophy and other sciences. And in his studies, he learned multiple languages. There was Khwarezmian, which was his mother tongue, but Persian also was the language of art in that region, and poetry. So he studied that. But Arabic was the language of science. He learned that and became an expert in it. All of his books were in Arabic, with the exception of a couple literary works that he wrote in Persian. But also he learned Sanskrit, Greek, and Hebrew, and Syriac, because those were the languages of the old texts of science. At the time, yes, there were translations that you can read, but if you want to go to the original and be able to read it, you needed to learn that language. And for him, that was an important thing, and that's why he learned these. That's why he learned these languages. So he lives there for he lives there and studies for the first 25 years of his life. But then when he's 25 years old, he acquires a patron for him to do actually scientific research. And that patron was Prince, or the title in Arabic is Emir. So Prince Mansur II of the Samanid kingdom. And Prince Mansour pretty much, at the time hosted him, and he hosted other scientists in Bukhara, which was the capital. So he moved to Bukhara, which was a big city, a metropolis at that time. And he was paid a salary, and his objective was, okay, now that you've actually learned and you're learning more, go and produce some science. And Bukhara was modeled after Baghdad as a center of science. The same way, it had a library, it had hospitals, it had multiple schools, mosques, places for housing students for science and so on. And its library was a very rich one, similar to that of the House of Wisdom in Baghdad at the time. So when he moved in, there was him, and there were other scientists. A lot of you have probably heard about Ibn Sina. In the Latin in Europe, it was Latinized Avicenna. And Avicenna was famous also in astronomy and in astronomy and medicine. And his book as Medicine influenced medicine sciences until today's world. And until today, there are certain aspects of his book that are still being practiced. So it was him and other scientists. And this actually is where the first debate that he actually starts getting into in science and his first work product. And that thing was primarily around, by the way, before I move on from Bukhara today, the city, decent percentage of it is preserved, and it is a World Heritage Site. You can go and walk through these old buildings and walk through all these schools where people used to study and produce all that scientific output, amazing scientific output. So shifting over to his first debate, it was primarily around Aristotle. And Aristotle used to say, thought process was that the universe is not changing. The skies, the stars are not changing. So there is no beginning, there is no end. The stars will not move or change. And a decent number of scientists at the time believed that and never really critiqued it or thought closely about it. So, and one of those scientists was Avicenna himself, Ibn Sina. He was Aristotelian. So he believed, just like Aristotle said, the stars won't move or change. Yeah, things can change here on Earth, but that's a terrestrial world. We live in that. Things can change here. But in the celestial world, nothing changes. There is no beginning. There is no end. And stars will not move and change. And to quote Aristotle, Aristotle was Plato's student. Plato, theorized there might be a beginning, there might be an end, there might be changes, but Aristotle was explicit, saying it is impossible for the universe to have had a beginning, like Plato said it did. And throughout history, from about 300 BC onward, that was the predominant thought process among people who dabbled in astronomy, that the stars don't change. We just observe them, record things, but there's nothing changing there. There's nothing to look there. And you will find very rare people contradicting them. There is John Philoponus during the Byzantine Empire in the 6th century, critiquing Aristotle's opinion, not from a scientific approach. He took it as a Christian theologian. He was a Christian theologian, and he said, no, Aristotle is wrong. because there was the creation of the universe, and because of that, there has to be a beginning. But other than that, and he wrote a thesis about it, but it was a theological thesis, not a scientific one. And so his criticism of him was primarily just being a Christian. There was nothing scientific in his conclusions or anything. Now, as time moved on, Aristotle's books got translated to Arabic. Scientists like Ibn Sina and Al-Biruni started actually reading those books. They started critiquing that stuff. Now, Ibn Sina signed up to what Aristotle said, despite being a Muslim, you know, and certain things that Aristotle said disagrees with Islam from a theological standpoint. Ibn Sina agreed with Aristotle, and he was very Aristotelian, not only here but in other aspects too. So Al-Biruni writes him a letter, and effectively in his letter, he tells him, you know, the world as defined by Aristotle, there's the celestial sphere and there's the terrestrial world that we live in. In the terrestrial world, yeah, a mountain can grow and then it can collapse over time. So things change here. That's according to Aristotle. But in the celestial sphere, the stars are, you know, there is no beginning, there is no end, there is nothing changing. Everything is fixed. And he said, I disagree with that. I think that there are no differences in spheres. I think it's all just one big universe. And everything has a beginning and everything has an end. The same way we see a mountain forming and then a mountain collapsing over time. That means, you know, and it happens over a long period of time that we can actually trace back in the books, sort of like, okay, certain things are changing here in the terrestrial world. Probably the same thing is happening in the sky with the stars. The stars are changing. They're being created at some time, and then they're dying at another time. And he explicitly differentiated that effectively stars have a creation moment, they have a dying moment, a decaying moment, and then there's their life cycle. So when he wrote that to Ibn Sina was pretty upset. He was very Aristotelian, very invested in Aristotle, and he wrote him a scathing letter. Very negative, you know, pretty much telling him, you're not a scientist, go away. Okay. Letters continued back and forth between the two, and that sort of like spun up a rivalry between the two, to the point that even Biruni at some point told Ibn Sina, you know, just go focus on medicine and let us look at the stars. You focus on what you're working on, the digestive system, all that stuff, good for you. Let us, people who actually want to actually observe the stars and understand them, look at those. And that rivalry continued with debate over Aristotle over the years after that. But, you know, the sad thing is Al-Biruni died 1050. And a lot of you know the Crab Nebula. The Crab Nebula blew up in 1054. And it was recorded by astronomers who lived in that region and lived throughout the Middle East, and astronomers who lived in China. So if only he would have lived, you know, 4 more years and recorded that, he could have actually been able to tie that to what star decay is. He wrote about star decay, that it's something that has to happen, but he couldn't figure out how does a star decay. So it's, you know, you look at history, if only he would have lived 4 more years, he would have gotten to observe star decay. And maybe if Ibn Sina was alive at the time, maybe he would have written him a letter back saying, hey, I was right. Something happens, they blow up. So that was their first debate. And then debates between them got further and further around Aristotle specifically. But before we get into their debates, we got to understand, now I've mentioned the terrestrial spheres and celestial spheres for Aristotle. We got to understand a little bit more in depth of what that means. So Aristotle defined the world into those 2 spheres. There's the terrestrial spheres, which are corruptible. Things change. We live in those spheres. And then there's the celestial sphere, everything in the sky, planets, stars, everything else. And those are uncorruptible, they're unchanging, and they go on forever. So, and those spheres are called, you know, objects that are within each of those spheres. There are different layers, and objects within those spheres are, they're living in what's called the crystal sphere. Okay. and they rotate for eternity with the fixed stars. Now, things that move faster are closer to us, and things that move slower are farther away from us, from a sphere ranking standpoint. The other thing about that universe is that it was the friction between the inner celestial sphere and the friction with the outer terrestrial sphere that was causing us to have heat. Without that, we wouldn't have heat. So pretty much it was saying it's the friction between the sky and Earth that's given us heat. Also, in that universe, according to Aristotle, you can never really have a vacuum state. Okay, because if you were to have a vacuum state, material will fill it right away. Aristotle's thought process was, hey, if you imagine yourself by the beach and you have the waves coming in and they're pushing everything around you, you're trying to dig a hole in the sand. The waves will come in and water will fill in that hole, or the sand will fall back in and fill up that hole. So you can never really have a vacuum state. Material will fill it right away. It cannot exist. But then also his argument against vacuum is that at this time they knew about friction, and they knew that friction and resistance slowed things down. So he was saying that if you have vacuum, you have no friction, you have no resistance, things will go at a speed of infinity. That's impossible. And by that, he rejected it. Okay? So going back to Ibn Sina being very Aristotelian, and al-Biruni actually started critiquing Aristotle more and more and evolving on that theory. The first one they disagreed over was Aristotle said nature abhors vacuum, right? Everybody knows that statement. Well, al-Biruni actually argued against that. The other thing that Aristotle said was orbits are circular, and you can't have elliptical orbits, although there was data from the time indicating the orbits might be elliptical. It was rejected because the data for the observation of the different planets, by being elliptical and different elliptical sizes, there would be gaps between them, and those gaps signified vacuum. So you can't have vacuum. That means the orbits cannot be elliptical. And then, as we said, the friction between the inner celestial sphere and the outer terrestrial sphere is what generated heat. That's what Aristotle said. And Ibn Sina agreed with that. And then last but not least was their debate over gravity. Why do objects fall down? And Aristotle said, well, objects from the four elements, whether it's earth, air, fire, and water, they fall down because they have a natural place in this universe. So they tend to move back to that natural place. That's the only explanation they can give to things, which is it has a natural place and it wants to go back to natural place. They couldn't actually understand or quantify what gravity is as a force or anything at that time. And al-Biruni would be the first one to actually start shifting that thought process. So, in regards to the first one, that nature abhors vacuum, al-Biruni, in his observations and letters to Ibn Sina, and he started writing that in his book, he noticed that matter has different densities. Some matter is compressible with low density. You think of a piece of a cork, even wood is compressible, or foam or something. That has a low density. There's a lot of gaps in it. It can be compressed. And some has a very high density. You cannot compress it. A piece of metal, no matter what you do to it in their time, you cannot compress a piece of metal. That means that there is a high probability that there is an object that has a state where there is very low density. It's effectively reaching vacuum or vacuum. And in his argument, he was effectively saying, so really nature doesn't abhor vacuum. Vacuum is a state that can exist. They knew about, heating objects will change the state of matter. They knew about all these different things. So it's saying, okay, one of his experiments was, let's actually put fluid in a jar, not fully filled up, and then let's heat up the jar and see what happens to the fluid as it becomes a gas and all these things. So they knew that matter can change between states. And then he was talking about, okay, there may be another states where it's effectively vacuum. Matter has been pushed into a very low density state where it's just vacuum. So that was their first, and that was his first, that was one of his debate points with Ibn Sina, back and forth about Aristotle. There is vacuum, and Ibn Sina is saying, no, there is no vacuum. The second debate point was, are orbits circular? And Al-Biruni looked at it and said, no, the data actually says they're probably on an elliptical path. And Aristotle was saying, no, you can't have an elliptical path because you've got different sizes and so on of ellipses. Those gaps between them will create vacuum. Planetary orbits are not elliptical. And following in his books, he would try to say, well, it might be an illusion, it might be this and that, but he insisted that they are circular. He was so invested in the concentric spheres theory. And El-Biruni looked at it, and he was an observational astronomer. He collected data, and then he came back and he said, no, this is elliptical. Now, a lot of you have heard the story of Johannes Kepler and how Johannes Kepler was trying to figure out the formula for planetary motion using Tycho Brahe's model. And Johannes Kepler was invested in the concentric celestial spheres model. And every time he built that model out, it collapsed. He tried it over and over and over, and it was very hard for him. And it wasn't until he started reading Al-Biruni's books that he started actually considering, what if it's an elliptical orbit? And then when he applied the formula for an ellipse, everything worked out for him. And that's how we have Kepler's planetary motion equations off of that. And even Kepler attributes the idea to Al-Biruni and, gives them credit for that. That's where I got the idea from. So again, the debate continues between Al-Biruni and Ibn Sina, back and forth, back and forth. Is it circular? Is it elliptical? And Al-Biruni was like, no, the data shows us, the empirical data shows us that it is elliptical. So another debate point was the friction between the celestial sphere and the outer terrestrial sphere is what generates heat here on Earth. And they went back and forth on that debate, but then Al-Biruni observed that pretty much the sun is made of fire. But, the sun is made of fire. That was what he theorized. And that those sun rays are composed of heat and light. The sun rays is what carries heat to us, and that he also concluded that they must have a speed. It takes a time for that heat to come over from the sun to us, because we can tell, we can tell that it takes a while in an environment for it to warm up after sunrise and so on. So there has to be some kind of a factor for sun speed at that level. So again, the debate back and forth continuing between the two, and Ibn Sina invested in, no, it's the friction between the different spheres is what generates the heat, and Al-Biruni talking about it more as like, no, this is a ball of fire that's emitting heat to us. Any questions so far? Okay.
This one goes back a little bit. Ron wanted to know the Latin involved when they were doing a lot of the translations from Latin from multiple sources into Arabic. Did the Arabic at the time, the question is it, has the Arabic spoken in the time of that period changed as well? I'm assuming it has, but is it significantly different than it is today? So
the answer is yes, there is a difference. Now, is it significant different? That's up for debate. So if you look at the history of Arabic itself, Arabic as a language, before Islam, there was no agreement on the alphabet or spellings or anything. Okay, and then Islam comes forward, and with the scientific revolution, people started to codify how is Arabic written, what letters sound like what, and how is a word spelled, right? And you come across that in English where effectively you have, different sounds for the same letter, or you have letters in the word that are not pronounced. So when they codified Arabic, they said, no, we need to actually figure out how all these things are so it becomes consistent and it becomes easy. And given that the Quran was revealed to Prophet Muhammad in Arabic, they used that as the reference and they codified the language effectively and its grammar. And you have books written on Arabic grammar about 100 years before that time, codifying how it's going to be written, how it's going to be defined, and all that stuff. And
So,
effectively, that became the consistent way Arabic was being pronounced and read and written and so on.
so would a modern Arabic speaker be able to read text from 3,000 years ago? I mean,
Yeah, not
English
3,000,
speakers
but
can. Old English, I would, very difficult, it's only 1,000
yeah.
years.
The answer is yes. So what happened, so although there was like, what you can call like the standard Arabic, which was what's used for lectures, used for books, and so on, you would find some variations of Arabic in the different regions of the empire that is effectively the standard Arabic mixed with some of the terminology of the local language.
Mhm.
Effectively, you realize that if I were to go to a previous slide here, that's a very good question, Ron. If I were to go to a previous slide here, this one here, you realize that at the time, the Arabic, upon the, start of Islam, the speakers of Arabic, the people who spoke Arabic before Islam were in present day Syria or the Levant, down the Arabian Peninsula, and then Yemen. That was the only region that spoke Arabic. Over here, Iraq, into Persia and Central Asia, they spoke Persian, and then on the periphery here, they spoke Turkic languages. In Egypt, they spoke Coptic and other ancient Egyptian languages. And then in North Africa, they spoke Amazigh languages and Berber languages and so on. And then in the northern periphery over here, people spoke Latin. And in Spain, or Visigothic Spain before Islam, they spoke I forgot what the name of the language was, but it was effectively a derivative of Latin mixed with a Gothic language. And effectively, because of science, because of trade, because of everything, a decent percentage of those regions, not only did they adopt Arabic as a language of science, but they adopted language as a language of everyday today business. So effectively, Arabic was spoken as a first language, within 200 years, from people by the border of, southern France, all the way through North Africa and then Egypt, through the Middle East, all the way down to Yemen. This region is the one that remained, Persia and east of it. That's the region that sort of like didn't adopt Arabic as the first language, but everybody knew very well how to read and understand Arabic. So that's at the time. And by the way, those patterns continued until today. If you look at where the Arabic speakers are today, they cover that, or what's the definition of like Arab countries and so on. That's this region over here. Now, the interesting thing is genetically, most of the people who speak Arabic are not Arabs ethnically. They're Arabs by becoming Arabicized through language and culture and so on. Now, looking at the evolution of the language throughout time, yes, like every language, certain terms, people stop using it anymore, and then new terms can evolve with the development of sciences. But would somebody today be able to read a text that was written, let's say about 1400 years ago when Arabic was starting to get codified and so on, the start of the Muslim civilization about 1400 years ago? And the answer is yes, they should be able to read that. They should be able to understand at least 80% of what is being said. Because until today, traditional Arabic hasn't changed. Yes, certain terms got added, certain terms fell out of use, but the general structure of sentences and everything, nothing changed, and even pronunciation and other stuff.
Okay, and we had another question from Yara, and there's several questions here, so let me just read this. When was Arabic officially started having a written form? I read somewhere that the Nabish, it's Nabatians
Nabateans.
were speaking Arabic, but writing in Aramaic.
Yes.
Formed Arabic letters from Aramaic Does that sound
Aramaic, yeah.
Aramaic? Sorry, excuse
Yep.
me.
Yeah. No, that's a very good question. Arabic, Aramaic, Hebrew, and some languages in present-day Ethiopia all of them come from Semitic languages. And Aramaic is the oldest of all of them that pretty much a lot of things evolved from after that. And the only two Semitic languages spoken today are Arabic and Hebrew. Initially, I don't know what the state is for Hebrew, but yes, initially Arabic started as a variation of Aramaic, as a local dialect by the Nabateans who actually inhabited present-day Syria into Jordan, this region here in northern Saudi Arabia. And they started actually speaking that variation of language. And after that, they started representation. They're representing with the alphabet that was used by used in Aramaic. Over time, the letters themselves changed from Aramaic to the current Arabic letters. And that history, because the Arabs before Islam didn't have a written history, it was all orally transferred from one person to the next, from one generation to the next. That history was mostly lost. How did that develop? In addition to the fact that, at the start of Islam, in Mecca, for example, only 4 people knew how to read and write. Arabic was a spoken language, not a written language. And if they were to write something, it was he had to find the guy, and that guy would write it down and then read it to people. But people in general didn't know how to read or write. And even when it came to like they would write an agreement or something, or a truce after a war or something, they would write it down in text. Then a neutral person would read the text, and then they would come over and dip their fingers in sort of like the ink, and then sort of like apply it over to the parchment or whatever it is, or piece of leather, and that was effectively them signing and agreeing to what that text was. So it was very primitive before Islam. After Islam came forward, it was like, okay, now we need to look at how the letters are written, make it consistent, how they are, so they added modifiers to letters that you see today in any Arabic writing. And also they looked at how are words spelled. Let's make that consistent too. And that's when it started getting codified. And yeah, when did the current, alphabet for Arabic start? We don't know.
Okay.
But the codification of Arabic became a model for other languages. It's one of the very first languages to get codified, that effectively, the organization of letters in many Latin languages, including English. Why do we organize the letters, A, B, C, D, etc.? It's because it took after the Arabic model for the alphabet by organizing the sounds.
Great. All right, I'll let you get back to where we were discussing the differences or the challenges between the scientists.
Sounds good. So yeah, coming back to this, so Ibn Sina and Biruni were debating these things. And here's the thing: to be fair to Aristotle and Greek philosophers and astronomers / astrologers at the time, their thing back then is, when the science is still very primitive, you're looking around you and trying to make observations of what's around you, and then looking at the distance, at the stars, at the planets, and trying to relate things and come up with theory. The theories of Aristotle for his time were the best that any mind could come up with. So, and that's what makes Aristotle great. The fact that they're not accurate or that they're wrong doesn't make him bad. It was, an evolution in the thought process. As humans, we never actually start with a fully flushed out thought from the very beginning to the end, right? We tend to take these scientific things for granted. Like, oh yeah, we know the sun comes from the heat. We take that for granted. But people back in the day, they didn't have a satellite. They didn't have a way to measure the sun's temperature. Yes, they know when the sun rises, there is heat. But how do I know that's not for another factor? But sometimes you have super hot nights and the sun is not there. you know, what is it? Is it the friction of the different spheres, or is it the sun? So for Aristotle, you know, those were the best theories he could come up with to explain the different phenomenon around us. The fact that he started looking at the phenomenon and trying to explain it by itself gives him a lot of credit. Now, he made step number one, and then others made step number two, and then three, and so on, until we have thought process evolved in what we have today. And as I always stress in anything looking at the history of science, it's not one civilization that gave us all. It's every civilization stands on the shoulder of the previous one, building on it, evolving things, and then handing it over to the next civilization that gets to stand on its shoulders and push the human thought process forward over and over and over, arriving to what we have today. So these thoughts had to start at that level to arrive at what we know today. Now, that's giving credit to Aristotle. Now, Ibn Sina himself, he was busy in many fields like any scientist of his time. He was a mastermind in medicine, but when you look at his work in astronomy, he didn't actually critique it as much as he should have critiqued it, like al-Biruni. Al-Biruni, he critiqued it where he was starting to arrive at theories that resemble our understanding today. So their biggest debate actually comes in, and it was regarding why do objects fall back to the ground? And going back to Aristotle's theory, which is, hey, everything has a natural place. So each one of those elements, the moment you release it, it's going to go back. It has a tendency to move back towards its natural place. And there is no talk of gravity or anything. So al-Biruni, thought about that. There was no conclusion. But then a contemporary of al-Biruni actually started developing something. His name was Abu Sa'id al-Sijzi, who lived in Balkh. Balkh wasn't too far away from Bukhara, where al-Biruni lived. And Abu Sa'id wasn't actually thinking about gravity or where things drop or anything, why things drop or anything. He was just thinking about, does the earth rotate, or is it the heavens that rotate around us? The common thought in antiquity is that the heavens rotated, were fixed, nothing moves. But then Abu Sa'id decided, hey, I'm actually going to make an astrolabe. And in that astrolabe, I'm going to put the earth as a rotating object instead of the sky objects as the rotating ones. So his theory was, no, it's the earth going around its axis, not the sky. Now, that sparked a lot of debate. And he got a fair amount of pushback from people because you think about it, people are thinking, okay, if you tie something to a rope and then you spin it around, if you have something on that object, nothing will be stable on that object. Stuff will start flying all over the place. We know the earth is stable because we're standing on it. So there is no way the earth is moving in their mind. And so his astrolabe and his design actually got a lot of criticism, and his theory in general was rejected by the consensus of the scientists at the time. No way. If the earth is moving, why aren't the trees and stones flying all over the place if the earth is spinning around its axis? Now, al-Biruni, as he was thinking about gravity and in his debates with Ibn Sina, he hears about Abu Sa'id and his astrolabe and the pushback from the scientific society that things will fly over the place. So he travels over to Balkh from Bukhara and pays him a visit. He sits down with him. Abu Sa'id shows him, hey, here's my design, here's how things work. And he shows him, this is actually a sheet from his book. He shows him, his calculations, etc. And al-Biruni comes out impressed. He's like, no, this guy is a legit scientist. He's using empirical data. He writes about him in his book that, no, this guy is very scientific in his approach. By the way, a contemporary of that time was another famous guy. His name was Al-Hasan ibn al-Haytham, famous in the Western world as al-Hazan. Hassan ibn al-Haytham, he is famous for optics specifically, and designing a camera obscura and refuting some of the theories around that the light comes out of the eye, falls in the object, and that's how we see objects into. No, light is an energy source, and starting to consider light as an energy source, not a matter, and a lot of these theories. But Hassan's primary contribution to science is the scientific method as we know it today. He's the first one who codified scientific method. And you see scientists at the time, As-Sijzi and al-Bayruni and others, have heard of those scientific methods, and now they're starting to apply it. Let's put a hypothesis, and his scientific method is what we know today. Okay, if you want to understand a phenomenon, let's put a hypothesis. And that hypothesis is clear about how it would pass and how it would fail. And then you go and collect observations. So you have empirical data, you analyze the data, and based on the data, you accept or you reject something based on that. And al-Bayruni was very influenced by that. And he looked at As-Sijzi's astrolabe, and he looked at it and the data and the calculations, and he's saying, okay, everything this guy is doing is right. But there stands the question, why aren't things flying all over the place, right? If you got objects on a table and you start moving that table and spinning it around, whatever glassware or dishes or whatever or silverware you have on the table will start flying all over the place. So that problem, stayed in his mind is like, okay, I got to solve this. But going back to Aristotle, things have their natural place, and that's why they fall back to them. And that also sparked another debate with Ibn Sina in his books. There is effectively a rivalry between Ibn Sina and al-Bayruni, Ibn Sina being Aristotelian and al-Bayruni being anti-Aristotelian, critiquing Aristotle and taking down these theories. But pretty much what al-Bayruni projected in his book, he said, you know what? I think the earth has a force that's pulling everything downward. And that force is at the center of the earth, because everything you drop will go towards the earth. It's not going to go right or left. It's just going to go straight down in its fastest route possible. So he's like, okay, there's a force down there. And that force is what's pulling us in. He doesn't call it gravity as we know it today. He just describes it as a downward force headed towards the center of the earth, which is what we know today as gravity. The other thing he theorized that the center of gravity of the earth also changes its position according to the position of the position that you're shifting the matter in. He was trying to understand potential energy. Nowadays, we know that the amount of potential energy, in other words, how fast an object is going to fall to the ground, will vary based on, the object's mass in contrast to something else, and also how high you raise it. We know today the force of acceleration is constant, but the velocity itself is a factor of how high it is. And he was trying to say, okay, when you shift an object to a different place, that amount of force coming from Earth varies. And again, he was trying to quantify potential energy. And he evolved that theory even later in 1037 in his book by saying that I think also heavenly bodies out there that have a mass and a weight have a gravity just like Earth. So he was saying he's the first, he's one of the first, if not the first, to say stars and planets and the sun and the moon are not just objects, in the celestial sphere with no known nature. Like in the old books, they used to call it the ether, undefined, pretty much. He was saying, no, this is an object just like Earth that has a mass and a weight and a gravity. Effectively, what he did is that he took the Aristotelian universe that Ibn Sina held dear to his heart and ripped it into shreds. And, it fed the rivalry, and some of the letters, that you can see like just the negativity between the two. And effectively, al-Bayruni telling Ibn Sina, just go focus on whatever you look up in the digestive system. Worry about that. Let us look at the stars. That's our business. Any questions so far? Okay, so effectively, Al-Biruni was, this is 700 years before Isaac Newton. This is 700 years before Isaac Newton figured out how to quantify gravity. He tried in his book to quantify gravity. He recognized that, there is the factor of height in his books impacting, the potential energy of the object and how fast that's going to fall to the ground. But he couldn't figure out how to quantify that force, which is effectively Isaac Newton figured it out, the change of momentum and acceleration and so on. And we get the the three Newtonian laws. And by the way, Isaac Newton does quote Al-Biruni on his research and his conclusions, effectively evolving them. And he's the one who effectively ends up codifying gravity as we know it today. So again, going back to Aristotle, that thought process wouldn't have started.
Quick question. Did Newton know about Biruni's work?
Yes, he did. He quotes him directly. So Kepler knew about Al-Biruni's work. Copernicus knew about and quotes him directly. And when he's quoted, they refer to him as Al-Birunus. They sort of Latinize the name. And same thing for Johannes Kepler. Galileo refers to him also in his writings, and Copernicus does refer to him too. There are many others that refer to him, but those four directly tie their works to his work. They consider their work an evolution to his work directly. And by the way, another dynamic that was happening at the time when I was talking about that period of peace, and you have people traveling and the mingling of different cultures, not only translation picked up, but also the duplication of books picked up. And with the trade, you can write a book and get it. There in every major city there would have been a market, like Bukhara would have had a market where you write a book and you hand it over, and it's a book market where effectively there are people sitting down and they duplicate your book. It was all done by hand. They would duplicate the book and then they would bind it, and then that book would spread all over the world with the different caravans. So a book that was written in Central Asia can be in Andalusia or Spain, in less than a year. And this is why Al-Hasan ibn al-Haytham, who was in Baghdad, and others who were in Central Asia, he was writing his stuff, and those guys within 1 to 2 years were heavily influenced by his writings and picking up, the scientific method is where we need to actually push science. This is how we need to observe and examine things and prove or disprove hypotheses. Any other questions, Clayton?
No other questions.
Okay, so Al-Biruni started quantifying gravity. This is effectively the very first recorded ideas of gravity. He started to quantify, but he couldn't figure out a mathematical formula for it. It wouldn't happen for 700 years when Isaac Newton figured it out. So he lives in Bukhara for many years, but then at the age of 44, he acquires a new patron. And he moved to Ghazni, which is you can see here on this map, the Ghaznavid Empire. He moves over from Bukhara to Ghazni in 1017 when he was about 44 years old, and he is appointed the Sultan's court astrologer. And we'll touch on what that will mean for him later in his career. Now, Sultan Mahmud al-Ghaznawi, just like other sultans at the time, were interested in, hey, I want to expand my realm. And he looked at it and he said, okay, what's technically unconquered land? And so he started an invasion of India. And he brought with him Al-Biruni. Biruni accompanied him in his invasion of India and traveled through India for years and years and years. He's written many books. And some of his books about anthropology and history were about the history of India. He's one of the very first people to actually start documenting the ancient history of India. and starting to starting to document what the Hindu religion is, and start to put that in writing. So he goes on, as as the army is moving forward. He's the court astrologer, so he had, he could bring in his equipment, he could do all these things, and he was always on the side. He didn't need to participate in any battles or anything. He was just a scientist, visiting towns and cities, recording things, and he brought scientists with him, to people who worked with him. So when they make it to an area called Nandana Fort in present-day Punjab in Pakistan, he finds that, hey, using trigonometry, I can actually take the angle between a plane and a mountaintop, so the horizon and the mountaintop, and calculate the circumference of the Earth. So he used that specific spot that's shown in the picture here. This is actually that's the remnant of the fort after that battle. He goes to the top of that mountain and starts taking measurements of the horizon. He goes by that fort in his writing, and he starts taking measurements of the horizon. And using trigonometry, he made an estimate of the circumference of the Earth. Now, depending on the different translations and the different estimations, because the units that they used to use back then are different from the units that we use today, the accuracy of his model of the circumference of the Earth falls between 10 to 20% accurate to what we know today. And, for his time, it was a decent calculation, not the best. But what's more important than an inaccurate calculation was the conclusions he drove from it. And the first conclusion of all was, he said, wait a minute, if we look at the circumference of the Earth, Eurasia only occupies 2/5 of the Earth's circumference. And then he started wondering, what's on the other side? And in his book, he writes that there is a high probability that geological forces that led to the rise of the Eurasian peninsula and Africa must have generated another continent on the other side. And that continent might even have humans in it. So he was effectively predicting what we know today as, hey, there is something on the other side of this planet, which is what we know today as North and South America. So he predicted that using empirical data off of his calculation of the circumference of the Earth. Now, so going back again, although it might have been an inaccurate calculation compared to what we know today, but the conclusion from it, with the thought process and everything, is amazing that he arrived at that conclusion. He is attributed as the first one on record actually putting something down in writing that we know for a fact, saying there is something on the other side, right? There are from previous civilizations, there are narrations of, sailors heading out west from the Phoenicians. He comes before the Viking invasions go south. The Viking invasions actually started invading North in Europe around 1000 AD. So it's happening at the same time, but they haven't made it across the ocean yet. So there were some Phoenician texts and so on about sailors sailing west, but nothing else actually came of that. But he's the first one theorizing with empirical data that, hey, there's something possible on the other side of the planet. Added to that, his writing was effectively, Christopher Columbus quoted him, in addition to Alfragani's writing about the circumference of the Earth, to go and convince Queen Elizabeth to fund his expedition. He was pretty much saying, hey, scientists saying there's something else, let's go conquer it. Contrary to the common belief that he was trying to reach India. Yeah, they said, okay, we'll find some land, and then eventually we can circumnavigate the Earth and get to India. He never got to go to India, but he did actually end up finding that land. And that was the proof that El-Biruni and others were actually accurate about that description. But El-Biruni was the first one who codified that. In addition to that, he actually started looking at the Earth projection. How do we actually map things out? And he came up with two different models for mapping out the Earth. The first one was modified during the Renaissance and got to be known as the Nicolosi globular one map projection. But he's the one who started it around 1000 AD. And the other one was the azimuthal equidistant map, which the azimuthal equidistant map projection is the emblem of the United Nations today. Effectively, when it comes to mapping, he got to be known as the father of geodesy, which is Earth projections and mapping and so on. He's the first one who started to codify that science. How do we draft these things? Okay. Any questions? Are we good moving forward? Okay.
Any questions?
Okay, I'll keep moving forward. So during his life in India and his travels and so on, and he read Ptolemy's books. And this is where we move from him critiquing Aristotle to critiquing Ptolemy. Ptolemy lived in Claudius Ptolemaeus, known as Ptolemy, lived in Alexandria, in the 2nd century AD, and he's well known for the Almagest that got translated to Arabic and became a source of a lot of knowledge that later got evolved from an astronomy standpoint. But one of the things he states in the Almagest is that the sun's apogee, which is the highest point the sun reaches in the sky, was a fixed spot that doesn't change wherever you go, and it doesn't change throughout the year. And in his travels in India is a big continent, and you go to different places, and when you're doing it over multiple years and so on, you get to start to notice this statement might not be true. So what he ended up doing is that he designed and built a mobile quadrant that he had, the scientists with him pretty much assembling and disassembling as they're moving forward with the army going from one town to the next. And he built that, and he started to measure the sun's position and recording the data. And his conclusion off of that was, no, Ptolemy's wrong. The sun's apogee is actually a mobile spot. It varies by season, and it varies by where you're at. Also, as he was taking these measurements, he started also at night, he was measuring the moon position. And later in the 1740s, Richard Dunthorne, who determined the acceleration of the moon, directly quotes the data from al-Biruni for doing his own calculations to get to his calculation of the acceleration of the moon. So al-Biruni, he used his quadrant to measure the position of the sun. He drove conclusions off of that, but even his moon data was good enough that 750 years later, that data was still good to do calculations for the acceleration of the moon. Another thing where he disagreed with Ptolemy was Ptolemy wrote a book called the Tetrabiblos, and that was Ptolemy's book of astrology. And as a lot of you know, the Almagest itself has a fair amount of astrology and running the constellations and their stories and interactions and all that stuff. And Ptolemy held astrology in a very high regard. Now, over time, al-Biruni started initially with critiquing Aristotle, then he started critiquing Ptolemy and being influenced by Al-Hasan's scientific method that everything needs to be empirical to prove that it's there, and we can't rely on pseudosciences anymore. He wrote a book. In English, it's called Understanding Astrology. In Arabic, it's Kitab al-Tafhim li-Awa'il Sinat al-Tanjim. And that book, he was critiquing astrology in a very negative sense. And he looked at it and he said, astrology is not a science. Astrology is a pseudoscience. It's people coming up with stories and connecting them together, trying to explain phenomena. There is no way you can test it. There is no way you can prove it. It's just a story. It could be a fun story at times, but it's just a story. It's not a scientific story. And he wrote an entire book saying astrology is not science. And then in his book, he dedicates a couple chapters to define what he calls astronomy. And astronomy in his world is empirical. And you can collect data, you can test it, and you can build conclusions off of it. And then for the rest of his life, he was explicit. So he effectively the first one to write a clear differentiation between astronomy and astrology, separating the two. Now, Islam coming, about a couple hundred years before him, astrology was already starting, because it was all these myths and stories that disagreed with the religion. People were starting to separate astronomy from astrology, but there wasn't a clear demarcation of what is what because they still couldn't test what's astrology from what's astronomy. And you see that in the translation of the Almagest through the different iterations. The initial iterations, they couldn't actually separate the two from each other because they didn't know how to how to separate them. But over time, with the development of the scientific method and the writing of al-Bayruni's book on astrology, understanding astrology, people started, okay, now we can test everything in an Almagest and separate what's astrology from what's astronomy. And you can see the differentiation when they would print the book after that. They never got rid of the astrology, but they pretty much separated the book into two halves. The first half of the astronomy stuff, and if you want to read some entertaining stories, here's the astrology stuff. It's also translated and printed. You can enjoy that stuff and read it. And that's because of al-Bayruni's work writing the very first differentiating factor between astrology and astronomy. If you can test it and prove it, then it's empirical, then it's astronomical. If you cannot, and it's pseudoscience, some story from someone, it's not empirical, that is astrology. And then after that, remember his title when he took his job he was the court astrologer, right? And that's the moment he actually switches gears and he refuses to be called an astrologer anymore by anybody. And he insisted on being called an astronomer, not an astrologer. Technically, you can call him the very first, self-identified astronomer per se. And throughout his life, in the rest of his writings, he held, he was vocal about his disdain for astrology. It's like, if you can't prove it and it's just hearsay and it's just a mythical story, it's just pseudoscience, let's not waste our time with it. So another thing well known from his legacy in that time was as he was taking his measurements, to gain more and more accurate measurements, he came across the issue of time. At the time, people knew how to measure hours, but they didn't know how to break down an hour. So he's the one who ended up actually dividing in 1000 AD, dividing the hour into initially into thirds and fourths and so on, 4 quarters and 3/3. But then after that, he said, okay, let's invent something. He called it the minute and then the second. And he broke down the hour into what we know today, the sexagesimal. It's a mouthful of a word, but it's effectively a factor of 6 or a factor of 60, right? We know the hour is broken down into 60 seconds, and the 60 seconds, the hour is broken down into 60 minutes, and every minute is broken down to 60 seconds. So he broke them down into factors of 60. Now, what he leveraged here is that the ancient Babylonians and Sumerians are the ones who started counting things to the base of 6. And that's why effectively they divide. That's why effectively they divided, for example, the month based on the lunar year. Let's count it as 30 days and other things. So he leveraged that and said, okay, let me take that more and divide the hour into smaller portions. We already know the day has 24 hours. And now let's break down those hours into 60 minutes and every minute into 60 seconds. And that's something that stuck with us now. A millennia later, we still count time in that factor. And for him, the objective was, I need to have a finer unit to take my measurements. I can't take things to the accuracy of 1 hour. I need to have, or a quarter of an hour, or a third of an hour. I need to have something more accurate. So that evolved during that trip, and that evolved during that time. He lived a long life, and during his life he published 146 books, 94 of them were in astronomy, physics, math, and geography. His most famous book was Kitab al-Mas'udi, the Mas'udi Law, which you'll find Copernicus and Kepler and others referencing that book. His other very famous book, Understanding Astrology, which you'll find people later in Europe, as they started to separate astrology from astronomy, referencing that as they start to separate the two from each other, and astrologers becoming true astronomers, 500 and 600 years later. His other 52 remaining books were in history, anthropology, and Indiology, which is effectively the history of India itself. He passed away in 1050 at the age of 77. And as I said before, if only he would have lived 4 more years until 1054, he would have seen the Crab Nebula when it went supernova, got to observe it, and probably respond back to Ibn Sina saying, see, I can see the star decay, it's changing, here's my proof. But unfortunately, he died 4 years before that. You'll find that Copernicus and others, and Isaac Newton, when they reference him, his name was Latinized to Alberonius, and he's referenced in this book. Isaac Newton references him when he starts talking about gravity, Kepler when he talks about elliptical motion, and so on. And so he effectively was a big influencer for a lot of astronomers that followed him. And those astronomers came from across the world, came from the culture, Islamic culture that al-Biruni was part of, and some who came from other cultures, specifically during the Renaissance and the Age of Enlightenment in Europe. And he is referenced by Umar al-Khayyam, even as-Sijzi, who was his contemporary, Zakaria al-Qazwini, Copernicus, Galileo, Kepler, Isaac Newton, and a lot of others. And he's one of the, when it comes to the Middle Ages, you can consider him, he was the Isaac Newton of the Middle Ages, applying, scientific method and empirical tests to astronomical theory and proving or disapproving that theory as he progressed in his work. And given that rich legacy and his influence, in the modern times, al-Biruni is one of the most famous scientists from that time when it comes to astronomy, and he was even honored in multiple occasions, like calling an island off of Antarctica off of him. And the Soviet Union, they discovered an asteroid and they named it after him. And even the IAU and NASA dedicated a crater on the far side of the moon, named it after him in honor of him. That's an image actually from Apollo 16 of that specific crater. So that's it for the hero for today. Questions?
I mean, I don't think we have any questions on the chat, but if anyone has any other questions, maybe they can unmute and ask. Yara had asked, will there be a part 3 next year?
Hopefully. I might try to continue down Ron's question around the different equipment that were used at the time and figure out a pattern to present it. I feel like that's a PhD dissertation.
Mm-hmm. I guess I had a question about 50 books produced in a lifetime of a career. What were the books like? I mean, are they like 100-page, I mean, words based on this? Is it comparable, or is it a pamphlet? Or
they're not, you can't call them a pamphlet, but okay, so you got to understand the printing process back then. Initially people wrote on pieces of leather or papyrus, which was not available everywhere, by the way. Like Egypt had papyrus because of the fertile land. And then in certain areas, people would actually find like a piece of bone or something to scribe on it. You'll find that with the Vikings and so on, as they start to scribe their runes and so on. So initially, it was hard to come by something to write on. The most common way was a piece of leather, or there was papyrus. And then at the same time the Abbasids were building the House of Wisdom, they came in contact with the Chinese. And the Chinese had a way of actually they've already invented paper at that time, which was much lighter, much faster to produce. and much easier when it came to production, that the Abbasids actually developed that and duplicated it and spread it all over the world. So you start to see, like in the very earlier times, you start to see books as being big and heavy, and and they didn't really contain a lot of words in it, because if you're using, an animal skin or a piece of leather, you'd have a book that's big, but effectively because of the thickness of the skin, it's actually not a lot of pages. But then with paper becoming more and more common in the 700s into the 800s, the 900s, etc., you start to see the books getting bigger and bigger and bigger and bigger. And effectively, they started getting into what they call encyclopedias. So he will write around a certain topic, and that certain topic, okay, here's book number 1, and then book number 2, and then book number 3. And then you realize this is somebody who spent 77 years writing books, and they would be working on multiple books at the same time. Because as he is traveling, he's collecting and researching, he's collecting data on astronomy, on physics, and anthropology. And he would be effectively writing multiple books at the same time. So whatever data he's collecting anthropology information, he's putting that into his anthropology book. If he is collecting astronomy information and he's testing it, he's putting it into his astronomy book, etc. So they worked on multiple books at the same time. And that's why they were pretty productive, pretty productive. Plus, they didn't have internet and YouTube to waste their time in the evenings. But pretty much, they were pretty productive. They were writing more than one book at the same time. You start to see books evolving over time and getting much bigger and bigger and bigger and bigger. And at some point, you start to see the books are actually easily within 200 to 300 pages. Even when they're printed today, they're much smaller, but they're effectively in the 200 to 300 pages easily.
Did you mention a date? There was a question on the board in the chat about what time in history did the paper from the Chinese actually make it to Arabia?
I'll give you an exact date because there is a specific battle. So it's effectively there. So the specific battle is called the Battle of Talas between the Abbasid Caliphate and the Tibetan Empire on one side, and the Tang dynasty in China. And in that battle, the Chinese lost the battle. And that battle took place around the Sir Darya River, which is a little bit east from where El-Biruni lived, and that was around 751 CE in July, in the summer.
And within his generation.
Mm-hmm. So that would be about 200 years before his time. So that in that specific battle, that was the battle where the Chinese lost. And as you know, at the time, the losing army pretty much fled, and they left things behind them, right? They left their, not only weapons, but, armies that back in the day, you can call them traveling cities because they traveled over long periods of time. And effectively, the supply chain system back in the day was you had cooks and you had people who traveled with the army to service the army. And you had scientists that traveled with the army, and you had, historians wanting to travel to observe the battle and things and write about it. So you would have books with the army. You would have equipment to even, as they write a book, okay, let's copy it and let's bind the book together. So you'd have equipment. So when an army loses and it leaves all that stuff behind, it goes over to the other party, the winning party. And then the winning party can look at that stuff and sell it, or look at it and say, oh, what is this? Let's learn from it. And effectively, that Battle of Talas in July of 751 was the moment that the Arabs learned from the Chinese, this is how paper could be made. Mm-hmm. And effectively, they popularized it and spread it. And this was the very first evolution. Like, if you look at the evolution of writing through, or evolution of books throughout human history, there are two very important steps that led to the widespread of books as we know it today. The famous one is Gutenberg with the printing press during the Renaissance. Gutenberg was important because he accelerated the writing process. Back in the day, somebody had to sit down and rewrite a book word for word. And you have people who are experts at doing that, and that was their job, which is literally copying books. And not only they would copy the books, they would copy the diagrams and so on. And there are books nowadays, you can look at them and say, okay, this was a copy, let's say from the 1100s, but then you look at a copy from the 1500s, the words didn't change, but the depiction itself changed because, you know, as they try to copy the paintings and drawings and stuff like that, they can't do it all 100%, and over 500 years it changes significantly. So that's it. You know, the Gutenberg printing press was a key one, but that only solved how can we duplicate things fast. The other one was the Battle of Talas, because the Battle of Talas was important because that's where the secret of how paper is made from China was taken over by the Arabs and spread all over the world. Now paper can be produced fast. So the medium for printing stuff, you know, became easily accessible for anybody. The issue is not finding a parchment or papyrus or finding a piece of leather to write on it and then try to bind it in a book anymore. No, you have paper prefabricated, pre-bind in a book, and then that book, you know, gets filled out after that. So you've eliminated a big dependency in the process that limited the amount of material that can be contained in a book. And now it's just a matter of how much can somebody write.
Ahmed, I have a question for you regarding Gutenberg. So when the Gutenberg press was developed, people were a little nervous at the idea of these printed works getting out to the masses and what they would do with that knowledge. They almost didn't want the press because they wanted the literature and the writings to be held in an elite group of people. Was there the same sort of restriction with Arabic writings?
Contrary. So let's understand the environment that Gutenberg came in. At Gutenberg's time, this was during the Protestant Reformation. And one of the things about the Protestant Reformation, before the Protestant Reformation, the Bible was only, and the Bible, you know, Old and New Testament was only the property of the church. It was written in Latin. People didn't know how to actually, the average person didn't know how to read Latin or understand it. And it wasn't widespread. Certain chapels or churches, you know, had bits and pieces of it, but you wouldn't really get a full copy of the Bible unless you go, like, you know, the main church in a major city, like in Paris, for example, or you go in Rome or in London and so on. But in the far-flung regions of any kingdom, you're not going to find a full copy of it. So there were challenges, you know, that the fear at the time with Martin Luther is that Martin Luther removed the very first barrier of the public being able to understand the Bible, which was he translated it from Latin to German. And we know what that led to effectively, the 30 Years' War and the Protestant Reformation. And there was all that fear from what is going to happen if the average person reads the Bible and interprets it for themselves. Fair enough? And now Gutenberg even poured more gas on the fire that not only people are able to read it, now this can be mass produced, because the first thing that Gutenberg printed was the Bible.
Yeah, exactly.
Now and because now this can be mass produced. So in the past, okay, it's translated, but it's not widespread. So we still have some level of control over it. But Gutenberg opened the floodgates. Anybody now can have a Bible, read it, and interpret it for themselves. That effectively meant that the Catholic Church, which at the time, as everybody knows, was in full control of religion and interpretation of religion in Europe. And through that, it controlled kingdoms and the masses and interfered in politics and did a lot of things, effectively lost control. And that's why Gutenberg, there was a strong resistance against him.
Right. So my question was, did the Arabic religion and Arabic culture and the Arabic language see the same change as we move to a mass production of text?
And the answer is no. I wanted to provide that context to actually contrast it to the other context. On the other hand, the way the Arabs actually approached language and writing in general is the reason they wanted to codify the way Arabic is written, the spelling and everything, is because they wanted, although it had a lot of benefits in science, now we can actually write and understand things consistently. Even now, 1400 years later, anybody can read the text and understand it. You know, other languages didn't get codified until much later periods. But Arabic got codified very early, that, yeah, anybody now can go and read something written 1400 years ago and will be able to understand easily 80% of what's being said. The Arabs at the time and the Muslims at the time were concerned that, you know, if any, you know, yeah, the Quran was recorded within 1 year of the death of Prophet Muhammad in writing, because people were worried, okay, we're going to lose it, so let's write it down. But then there was the other thing, which is, okay, as we're writing it down, they started having disagreements. How is a certain word spelled? How are all of these things, you know, going to be captured? And that's what actually sparked, you know, the idea of let's codify how it's written. And then they codified it. But then effectively what you see after that is that the rulers were saying, okay, to make sure that we have consistency and people are not having inaccurate copies, they started actually printing it and sending it to the major cities. So they print, you know, the first Quran was gathered in Medina, but then they made copies. One would go to Egypt, one would go to Iraq, one would go to Syria, and then they started actually spreading it more and more. And that's how the book itself got preserved until today, same exact copy over 1400 years plus. The same thing that effectively also influenced sciences, because now you have a movement within society where books are becoming more readily available. Books are becoming, you know, printing something and keeping it consistent. That is the thing you got to focus on, and then print the books and spread them. And that's why, you know, Baghdad was so loaded with books at the time that when the Mongols, after they destroyed Baghdad in the 13th century, and they wanted to cross the river to the other side and continue their invasion, the easiest thing they could grab and dump in the Euphrates at the time was they went and grabbed enough books. They were able to find enough books to barricade the river and for the army to cross. That just tells you how many books there were in one city. This was at the same time that certain cities in Europe, if the city had like 10 books or 5 books, it would have been considered, hey, this city has a library per se. So the proliferation of books throughout, you know, the Muslim world and the Middle East didn't see that kind of backlash. If anything, it was welcomed. It was, yes, let's see it in writing because now it is confirmed. And documentation was very important for them. So to answer your question, Ron, there wasn't that backlash. If anything, people looked at it as positively. No, let's record things down, make it consistent. Let's come up with a consistent methodology around recording it, and then let's, you know, copy and spread.
That's excellent. Thanks, Ahmed.
Oh, you're welcome. And by the way, you start to see the evolution. Like there are certain city centers like Cairo and Damascus and Baghdad and Cordoba, where you see people from around the world. You'd have people that literally are just traveling from one city to the next. And what they're doing is they're going to the book market, identifying, okay, what are the books in that market that I don't have, and then purchase copies. And by the way, purchasing a copy back in the day meant that you placed the order and then you'd wait a couple of months until they copy it and then they review it and then they hand it over to you. So they would go in the city, and effectively that traveler would live in a city for about a year or so until he gets the books, and then he moves on to the next city. Okay, what are the books in this city? And then et cetera, et cetera, et cetera. And his business is he's acquiring books that are being copied, you know, that are in the city, and he's getting those copies. He's also offering, oh yeah, you guys don't have these books. How about while I'm here, you copy them and you pay me for that. So effectively, you start to see a trade around books and people moving from one city to the next. I have books you don't have. You have books I don't have. You buy some of what I have and you give me money and I'll buy some of what you have, and you have a trade. And you have people making a living going from east to west, copying books and transferring books. It became a pretty lucrative business.
Well, I would have had that job back then.
It would have been an amazing job. Imagine you're the guy going, first thing, you're traveling the world. You're going from one city to the next. So you get to experience multiple cultures and civilizations and so on. And not only you do that, you go to the book market, You see everything that's out there as the book is being, as the book is being copied for you. You're selling the one you have, but you're also reading what you have, and you're acquiring all that knowledge from all the different books and the different writers. And many of those people, some of them actually, you'll find they end up actually saying, you know what, I've read enough books. I need to settle down and I need to actually do my own scientific research. So that by itself was a step into somebody becoming a researcher.
That's very cool. Thank you.
Thank you, Ron. Yeah, that is a cool job. Any other questions?
Do you mind just saying the name of that battle in Arabic for me?
It's Talas.
Perfect, thank you.
And if you want to look it up, it's spelled Talas, or in Arabic, Ta Lam Alif Sin.
Shukran.
You're welcome.
Got another question, Ahmed.
Go ahead, Ron.
It was back in the chat-a-ways, but when you were talking about the debate with Ibn Sina, it seemed through your graphics that they were both espousing the heliocentric belief. Is that true?
That is actually a very true statement. As I mentioned before, initially people started, the Islamic astronomy, they started with a geocentric model. But then you start to see people questioning the geocentric model. And by by 1000, everybody is like talking, no, it's all heliocentric. All of his writings are heliocentric. And many people who actually look at Copernicus, who actually quotes al-Biruni and was aware of him, he quotes al-Biruni in everything except that al-Biruni believed in a heliocentric model. So some of the people say maybe Copernicus left it out on purpose. We don't know why. Maybe that specific book, because again, he wrote 140 plus books. Maybe that specific book where he writes about heliocentricity, maybe that never made it to Copernicus, and maybe it made it to Copernicus, but Copernicus wanted to present it in his own way or shape or form to the public, and effectively he got attributed with it. But yeah, by that time, it wasn't al-Biruni's idea or Ibn Sina. It effectively became the fact that it's a heliocentric, not a geocentric model, at least 100 years before, if not more.
Well, and Copernicus wouldn't live to see the reaction to his book, but I wonder if there would have been some vitriol because his math didn't work either, because he was a circular orbit guy.
Yeah. Al-Biruni was heliocentric, circular, figured out gravity. Yeah, for his time, it was pretty impressive. And you look at it, what he did was the perfect stepping stone that others like Kepler. He's like, okay, that's a good idea. He looked at his writings and it's like, that's a good idea. He quotes him on the elliptical orbit, and then he goes and figures out the equation. Isaac Newton looks at the whole gravity thing, is like, okay, that's a good idea. He quotes him there, and then he figures out the physics and the equations for it, etc. Any other questions?
We can keep you here all day.
Well, thank you. I enjoy history of science. I always look at the evolution of human thought, and I'm always entertained, because nowadays we tend to take a lot of things for granted and never really think about them, especially the newer generations. And look at the older ones as being, the older generations as being primitive, or in a condescending way. And I look at that and say, no, every generation is brilliant in its own, and that every generation needs the one before it and the one before it to stand on its shoulders and progress forward. So going back to the how thought developed over time, understandings developed over time, is pretty good. And it's pretty entertaining, because somebody today can look at Aristotle and read everything Aristotle read and said, oh, this is stupid, Aristotle's crazy, right? And if they say that, okay, they have a point, but in reality, no, they don't have a point, because Aristotle was trying to explain things based on the tools he had and the common understanding at the time. He evolved the understanding of his time. Now, his thought process stopped at a point, and what it took was about, 1,000 years plus, about 1,200 years later for somebody else to evolve it. And al-Biruni evolved it significantly. And then he stopped there. Yeah, there were some evolutions after him, but effectively, like for example, on gravity, it didn't really evolve much after al-Biruni until Isaac Newton came 700 years later and evolved the concept of gravity, right? And now we have equations about it. And now we're looking at, gravity. Now the whole concept of gravity, Isaac Newton didn't know about gravitational waves or any of that. These things are black holes. That thought process has evolved today into a totally different understanding. But we couldn't have arrived at gravitational waves without Isaac Newton. Isaac Newton couldn't have arrived at what he did without al-Biruni. Al-Biruni couldn't have arrived without Aristotle. So everybody stands on the shoulder of someone else.
With that in mind, and with the context of astronomy, is there a book that you recommend for the regular humans like us to read about how it evolved, the history of the science in astronomy that will be friendly?
I couldn't find a specific book that encompassed everything. I did actually come across multiple research articles along the way that were very good, informative, especially the debate, the writings between Ibn Sina and al-Biruni. Initially, they started with direct letters between the two. And then effectively, at some point in their rivalry, they stopped actually corresponding with each other. But effectively, each one of them in their books, they're writing in their books the refutation of the other, if you want to call it. Mm-hmm. And each one, and you can tell al-Biruni would read, Ibn Sina's latest book, and then he'd say, no, here's a refutation of Ibn Sina. And then Ibn Sina would read his book, and then al-Biruni, and then would write a refutation of al-Biruni, and then they would go back and forth. I try to simplify it, but it started initially with letters, given that both of them lived in the same city. Both of them had the same monarch patron, per se, who was sponsoring them for their scientific research. And since both of them overlapped in astronomy, they wanted to talk, right? Like any two scientists, if they're in the same university doing similar research, they'd want to talk. They wanted to talk. And the way at the time was, okay, I'm going to write things down, give it to you in a letter so that you analyze it and respond to me. And that's how our debate started, except it went down south really fast between the two, because Ibn Sina was very, invested in Aristotle and couldn't depart from Aristotle's ideas and considered it offensive. Al-Biruni, initially, when you read the letters in Arabic, they're entertaining because initially he's using soft language against Ibn Sina, but then in the end, he's just telling him, just go focus on medicine, whatever you're looking at in the digestive system, and leave us. We like looking at the stars, and leave the stars to us, which is effectively, a subtle insult, per se.
Yeah, but clearly he did have a point now that we look at the history the way it is.
Absolutely, he did have a point. And when you read it in Arabic, it was entertaining because he does it. There was no vulgarity, but he does it in a very entertaining way that it's pretty comedic in the end.
Are these letters public domain?
Oh yeah, they're public domain. Yeah, you can write about al-Biruni, Ibn Sina's correspondence, and you'll find it all. And there are many articles and research papers around them, and their books and their debate and so on.
Thank you so much.
You're welcome. I think a decent percentage of them are even preserved in the Library of Congress. Any other questions?
Yeah, I hate to get ahead of part 3, but you took us up to the 13th century. What happens next?
A lot of things. Well, the 13th century is interesting in the world history in general for a very simple factor, which is the Mongol invasion. Because the Mongol invasion, you have the Middle Ages, you have antiquity, which effectively ends with the rise of Islam. You have the Middle Ages, and then you have in the early Middle Ages, and then you have the late Middle Ages with the Mongol invasion, because the Mongols introduced a lot of factors they, as you know, they invaded from present-day Mongolia. They went down to China and into, even they went and tried to invade Vietnam and so on, and the Koreas. And they went as far, west until they got defeated in present-day Palestine. And they also, in the north, they conquered all of what we know as Russia and into Poland and made it into Hungary. But effectively, they brought a different dynamic, and they are a main contribution of certain aspects of the Renaissance, actually starting in Poland, for example, because they broke down the barriers when they ruled that region, including Poland itself. Scientific research, which was being done in the Muslim world, the Mongols themselves didn't care much for science, but effectively they cared about trade, and trade meant the transfer of books and knowledge. And scientific research that was taking place at the time in the Muslim world started being transferred over to Eastern Europe, to Poland and some of these regions at the same time. That's also the same time that the Crusaders were departing from the Middle East as they were being defeated, and they were taking with them aspects of things that they took that they earned from the Middle East, including books going back to Europe, and starting to feed the Renaissance in France and the Renaissance in Italy. And at the same time, the Muslims were on the receding end in Spain. And as their cities were being taken over during the Reconquista, libraries were being taken over by Europeans. And you start to see the Muslims at the beginning started an era of translation and then critiquing books and then evolving thought process. You start to see the Renaissance starting from those roots of the transfer of information. They started with translating books, and then they started critiquing and then evolving the thought process. And initially, for a couple more centuries, that's going to happen parallel to the rise of the medieval Islamic history, which was a golden age. But then at some point, the Muslim nations sort of like start falling behind on sciences and so on, and effectively governments start falling behind, and Europeans rise with the rise of colonization and so on. So that's a very quick summary of what happens after that. I always love your questions, Ron, the open-ended ones.
Well, I always like how you fill them.
Oh, thank you. Appreciate it.
Yeah, well done, man. Hey, the Almagest went from Ptolemy into the Middle East, and I'm sure it primed the pump for a lot of activity. Was there a book that came back out of the Middle East into Europe that equally ignited the Renaissance?
Yeah, it's effectively the Almagest. So the Almagest, when it was translated, and actually, I had it in my previous slide deck, which I captured here in the appendix. I'll just share this slide here quickly. So the Almagest, yeah, written by Claudius Ptolemy, and then it remained in Greek for its lifetime. And at some point, it became sort of like a deserted, neglected book. With the Muslim conquest of Syria, and there were some Greek books in Damascus, you find that the very first attempt to translate it was in 700 AD. And they tried to make that translation. We have bits and pieces of that translation surviving, but it never actually made it. And then about 800 AD, there was a second translation that wasn't actually in full, but then you have an 829 by a guy named Al-Hajjaj ibn Yusuf ibn Matar. He's the one who actually made the translation that stuck with us until today. He took it to Arabic, and then the Arabic version is the one that got translated to Latin. Now, the interesting thing about the Almagest is that it was called, the Latin name for it is Mathematica Syntaxis. It wasn't Almagest. And it was the Arabs who combined part of it is Arabic, the L, and then they took the Greek word for majestic and Arabicized it, and it became Al Majesti. Okay, and within the Arab, scientific community, it was known as Al Majesti. Okay, but then during the Renaissance, when it got translated from Arabic to Latin, it went from being called the Al Majesti to Al Majest. But it's effectively the same book. The one we have today, that's the original Greek copies, there are no surviving Greek copies, by the way, of the Almagest. There are no surviving Greek copies. There are surviving Arabic translations of the book. And there are surviving Latin translations off of the Arabic for the book. Did that answer your question, Ron?
Yeah, that's excellent. Thank you, sir.
You're welcome. Any other questions?
Any modern day centers of astronomy that are in the Arabic world?
Unfortunately, nowadays there aren't real centers like it used to be in the Middle Ages. I know there is an attempt for reviving astronomy. I know Morocco, for example, has been trying to host multiple observatories. I know in Turkey, they're trying to do that. In Central Asia, they're looking at that rich heritage and saying, we were like that in the past, we need to bring that again. So, it's taken different shapes or forms. Some of it is renovating old remaining structures that served as, astronomical observatories and so on, and bringing back those books and recovering them, the ancient texts. So there's that's from the historical standpoint, but also there are attempts now to start, okay, let's start building our own observatories, modern ones, and start doing some research. Nothing still yet at the level that you see, in the US or in Europe, but hopefully it becomes a new start for a new revival. I always love astronomical research wherever it comes from. It's always good.
No, that's cool.
Okay, any other questions?
I don't mean to hoard your time, but I've got another one.
Go ahead.
I know a lot of astronomy has grown, or especially astrology has grown out of a spiritual sense of the heavens and the earth and what God provides above us. I've been trying to work on American Indian knowledge of the stars. There was a bill passed in the Minnesota legislature that indicated that we need to bring in indigenous voices. The challenge for me has been the indigenous voices with regard to astronomy are very spiritual and religious in nature. So it's hard for me to present that in a scientific context. Did Arabic astronomy have a religious essence wrapping it up? Or from what I see, it was much more of pure science and empirical data?
So given the nature of the religion itself, it was very heavily in pure science and pure data. And there is a reason for that. Here's the thing: Arabs before Islam were big on skepticism. They looked at the celestial objects and they associated some of them to their pagan gods at the time. They looked at comets as like a good omen or a bad omen. They looked at an eclipse as a good omen or a bad omen. But it wasn't until Islam came and pretty much set the expectation that no, those are all natural objects. They have nothing to do with God. They're the creation of God, but they don't actually demonstrate the will of God or anything from a theological standpoint. And a manifestation of that is in 632 AD. We know that because there was a solar eclipse that took place. And in that solar eclipse, that same day, Prophet Muhammad's son passed away. And a couple hours after he passed away, everybody in Medina at the time knew about it. People came, and then the eclipse started happening. So people came out saying, oh, the sun was eclipsed because it's sun, it's sad, the heavens are sad because the prophet's son passed away. Okay, so still some people still had that astrological superstition, from the days they were pagan, although they converted to a new religion, but they still have those remnants, and they haven't fully adopted the ideology of it. So when Prophet Muhammad knew about that, he came out and gathered everybody. And this is in recorded, religious text, that the sun and the moon do not eclipse because of the death or life, meaning birth, of someone. They are governed by God's rules and laws, and they move based on that. So effectively, it's saying, no, this is not, abandon the superstition. Oh, sorry for that. Abandon the superstition, take a scientific approach to it, and try to understand it. God has set up rules for this universe, for the motion of objects and everything. That's what governs things. And it's not superstition that's actually going to lead to this. So the Muslims took a very rationalistic approach to science. And this is why when it came to astrology, from the very beginning, people didn't feel comfortable with it, but they didn't know how to separate it from astronomy. They didn't know how to separate the science, the fact from fiction. And it wasn't until al-Biruni, and writing his book, Understanding Astrology, he is the first one to write, here's the guidelines to separate pseudoscience from empirical data, which was effectively applied the scientific method, tested, and all that stuff. And if it checks out, then it is scientific. Otherwise, it's pseudoscience, it's astrology. And given that not only he wrote that book, his disdain for astrology throughout the rest of his life, and what he wrote about it, and he would tie it back again into, this is what Prophet Muhammad said, abandon astrology, pretty much.
Oh, that's awesome. See, I get that sense from what I have learned and read, but to have you confirm that, that's excellent. Thank you so much, sir.
You're welcome.
Is his book available to purchase, or is it also public domain?
It's public domain, and there are actually copies that are preserved in museums of his books. You'll find, I couldn't find, like I found, for example, in the Met Museum or in the Library of Congress, like certain books, like the Book of Fixed Stars by Sufi, they put together a full scan of the book, and it's out there. You can download it in PDF, and when you read it, that's really nice read. His books, I found sections of his books, but I found a lot of research papers referencing his books, and certain things, within certain universities, you had to be within a certain library access to get it. I couldn't get to those. Any other questions?
Looking forward to part 3.
Same here.
You're a national treasure, sir. I'm glad you're ours.
Thank you, Ron. You too.